explaining certain topics for the SIPs. So maybe I could just share them with you. It's like a couple of Quarto files which you can render on your RStudio. So I'm going to share with you this Quarto document. I don't know if I can share it through here, or I'll make sure that you get this, but I'll explain it. So basically, we'll be watching the content of this document which I wrote in this Quarto file. And you simply, whenever you have a Quarto file, you just load it with your RStudio and you render it. So basically, that's what the file does, and it will open or populate the PDF
Yeah, that's
well
fine.
designed and crafted. So before we start, what's this about? I am Federico Alegría, and I am part of SIC rstats club. And as a part of this SIPS program, we created some guides for dealing with certain specific concepts. So I was in charge of data visualization, but rather than an introduction, you guys need to understand this content more as a glimpse into data visualization from a very specific paradigm, which is the grammar of graphics, or the theoretical background of the ggplot. So, who am I? I'm a researcher in social science. I'm very interested in studying photographic behavior as a social practice, and I am an advocate of visual data. What we will learn today with this document is there's another person joining us. A thing or two about visualizing data within a research project. And welcome. And something about visual decisions amidst basic data characteristics, because we cannot conduct or we cannot render a graph if we don't consider first our data. And that's very, very important. A bit of this layer structure of the grammar of graphics, which is the background, as I said, from ggplot is built or developed from. All right. So this thing or two that I was saying earlier is that the first, you cannot escape data wrangling, is something that you need to perfect and practice a lot. One of the greatest ways of learning data science in R is through community. So you can join us at the SICR Stats Club, and we basically push each other into advancing in our own careers. So that's very important, and developing wrangling skills is a crucial step in your data science career if you're interested in this path. And from exploring to publishing, data visualization is inevitable. You will always be dealing with this stuff. So a very basic thing that we need to know here is that ggplot works with rectangular data. And what is rectangular data? It's a collection of values. I'm like reading exactly as in the data science, art for data science book, which is a lovely introduction into the world of R. I'm sure you might know this book already, but I'm taking this definition from there, right? So rectangular data, it's a collection of values that are each associated with a variable and an observation. So whenever you guys receive a messy spreadsheet with data merged into cells, for example, from Excel, or that one row takes into consideration several columns or vice versa. All those cases in which one observation cannot be linked solely to one variable is what we can call messy data. So tidy data will respect this principle. There are a lot of data sets that do not naturally fit in this paradigm, including images, sounds, trees, and text, but rectangular data frames are extremely common in science and industry. And we believe that they are a great place to start your data science journey. So if you follow this book, you'll be presented with all the packages and all the needed stuff for you to get the basics of these concepts. And yeah, learning R and I'm guessing other programming languages is a very self-paced thing to do. But yeah, practice is something crucial. Rectangular data or tidy data comes from tidying, also known as data exploration or simply making sense out of our data. So there's no exact recipe for the exploration part. For me, it's where you can be more creative. And even if your juices aren't flowing, you can even print the head of a table and ask ChatGPT, hey, which things can I do with this data set? And I'm telling you this because I advanced a lot in my career as well, participating in the Tidy Tuesday challenges. Speaking of Tidy, um, so these challenges, these Tidy Tuesday challenges, present us with weekly data sets that we can explore, and when they're real world data, and it's great. So whenever we are maybe stuck and we don't know what to do with certain type of data, because there are a lot of types of data that we can encounter in these challenges, we can ask ChatGPT to give us some insights or some clues uh, for the road to be taken, you know. So this process, it's very cyclical and will support a lot in visualization, maybe not beautiful graphs yet, but decent graphs to understand the behavior of our data. That's the most important thing to know in using data visualization. As I said earlier before, it's something very inevitable. So we take our data and we start wrangling with it. And after this process takes a lot of iterations, we can communicate something that can become in the form of a paper, because that's like the golden standard, but we can also communicate through places like our club. So you can publish your graphs, you can share your stuff, also social media. There's a lot of things around the Tidy Tuesday challenge. So you can communicate beyond the paper, and that's something valuable for you to know, I guess. And as explained before, one observation can only be linked to one variable. That's it. So this is like the illustration of we have variables on the columns, we have cases on the rows, and we are only allowed to place one in each, like one variable and one observation, and those are the values of our tidy data set. There are a lot of visual decisions because not all graphs look good or are like preconceived to work with all types of data. We have different types of data, and depending on the data that we have, we can take those visual decisions. We can talk about distribution, we can talk about correlation, when two variables correspond with each other. we can talk about rankings, we can talk about part of a whole, or like percentages. We can talk about time, evolution, and we can talk about spatial data, like latitudes and longitudes for showing a map. And we can also see things in the sense of a flow, like the Sankey's graph, for example. So let's make sense of this conundrum. Non-metric and non-ordered data is like the two things that you need to know. Non-metric and ordered data, metric data with no decimals, and metric data with decimals. So these are like the four types of data that you can encounter most of the times. So non-metric can be anything that it's not a number. For example, text. You can have long strings of text, or you can have short strings of text for colors, for example, red, green, and blue. And also, when we say it's non-ordered, it's because there's no hierarchy. Red is not greater than blue, and vice versa. So there's no order within them. So that's like the first type of data, and it's in a sense more qualitative than quantitative. But yeah, we can count those strings. We can still be dealing with non-metric data, but with certain hierarchy, like scales from agree to disagree, the famous Likert scales. Those are still non-metric because they are not numbers in the strict sense. They're more representations of, this level I'm assigning this number, and that's it. And then you can rebuild the scale, but in simple terms, it's more like a quality than a quantitative feature. Then we have metric data with no decimals or integer values, 1, 2, 3, 4, 5. And we have metric data with decimals. That's what we call doubles in data science. It's like 1.15 something. So as you see, we are advancing in how much our data can provide, because if you have a very specific number, let's say temperature, you have something with decimals. There's a true zero, and you can transform that into heat or thermical sensations like warm, cold, but you cannot go the other way around. You cannot transform cold into 3.5 degrees, So whenever you are collecting data, try in the most scenarios to collect metric data rather than non-metric data. Because of these things, you can transform metric into non-metric, but you cannot go the other way around, and that's very important for you to consider. So we have data which have these qualities that can all be counted. That some can be counted, some others cannot, like non-metric and non-ordered data. But some others that, I was dealing with logical values here, so don't worry about that. But here I'm talking about the four types of data that I said before, like non-metric data, non-ordered. So non-metric and non-order, we can have non-metric and order, and we can also have non-metric and logical, like true and false. And you can have metric, which is binary, 0 or 1, integers, which are like 1, 2, 3, 4, 5, and doubles, which are the decimals. So these that cannot be counted, I remember now, is what the earlier quote about the images was about. Like, some data can be treated in this rectangular fashion, but some others cannot. So yeah, false is for those cases in which data cannot be fit into this paradigm, like images, which is the field that I study the most. And here are some examples of different types of visualizations that we can build from different types of data. Like the types of data that I just mentioned are, I'm taking them from here, like distribution, correlation, ranking. Then there you can have a lot of examples of different types of visualization that you can do. I'm very honest, I'm like super noob here. I know like five that I have reproduced of this, or six maybe, but yeah, it's a very long journey that cannot be covered in some scarce sessions. It's more like a daily thing, and you can find your purpose with the challenges. So this is the last slide from the presentation, and then we're going to move to the other document. ggplot works with this layered structure, like adding things. And there's a lot of stuff that can be added, but not all of them are essential. Like, three are like the most essential: the aesthetics, data, aesthetics, and geometries. Those three are like the essential. Yes, they have to be there for you to have something. The other ones, facets, for example, which help us to display different graphs by a specific group, is not necessary for all visualizations. Also, statistics, like providing you with a linear correlation, or these bar plots, which are sometimes a little bit tricky. And the coordinates had a lot to do with the position where you are placing your stuff, because the ggplot can be seen like as a blank canvas in which you can draw. I've seen a lot of people doing art stuff with ggplot. It's very curious. But yeah, we're building from a blank canvas this image. So now we're going to move to the other document, which is this one. As I said, this thing died. Oh, another thing, right now that I'm juggling through my tabs, is that Posit, which is the new name of our studio, it's like slowly pushing to the people the new IDE, the Positron. And I encourage you guys to check it out. It's not quite done yet, it's not perfected yet, but I think it's good to be on the know of, like the new trends, and yeah, that. So let's advance through this document, and I'll be explaining more the things that are here in the code chunks. So maybe I should just go through and run, because I'm not going to be reading the document for you guys. I'll be just like going through the figures. But yeah, I think this is very important to know why are you using is Positron easier or harder? Let me see, chat. well, is positron easier or harder compared to using? I think it's a little bit faster. It's not like, I can show you here. It's like, it's a little bit faster than RStudio, and it's like built from code OS, which is like the base of VS Code, if I'm not wrong. But it's very, very, very similar. It's like, it's more efficient, and it's like the new refreshed version of RStudio, because RStudio is like a little bit old, as I'm aware about. You know? So the most important thing that we need to consider when asking ourselves why the struggle of using code and not a graphic user interface, because of reproducibility, and we science need to know what has been done with data, because it's not the same if you are presented with a figure and you can reproduce the figure yourself and see if there has been some polishments made to the data, like filtering certain outliers or stuff. But you can see that, you can check it out for yourself. But when you are presented with a figure with no code to reproduce it, it's like you need to have faith in that figure, and that's very uh, hard to do when dealing with science. So most for me, it's about that. Why all the struggle of learning about ggplot and stuff? It's because of this reproducibility, but a lot of other stuff. It's consistent. um, it's very highly customizable. There are a lot of other packages that are like crafted around this paradigm and expand your vocabulary language. At the end of the document, I'll show you one package that does that. And it's very highly integrated with the tidyverse, which, if you are not aware, it's like what made R popular, I think. And it's like a very essential package for doing lots of stuff with data science. So it's very, congruent and coherent with that way of thinking. Here is a guide for installing and loading the ggplot. You just need to install packages, and that's all you have to do. I'm going to be here. So if you only load ggplot2, I'm going to zoom it a little bit more. If you only, whoa, where is it? If you only type ggplot2, it'll only load ggplot2. But sometimes you need to do some wrangling before piping your data into a ggplot. So it's more recommended to load the whole thing altogether, the tidyverse. And from there on, let me see here. All right, so here what I've crafted is like a little template, if you can say it, for producing a very specific graph, which is a dot plot, where I, like scatter point graph. We can do it from scratch, calling ggplot and then our data. And then we give the extra argument for the aesthetics, and we define the variables that we are interested in seeing in the graph. But there are some verbs that you need to learn, and it's very important for you guys to know them. These verbs from it's the plier package, if I'm not wrong, from the tidyverse. Let me see. yeah, deployer. So these verbs or these words are very helpful for reducing the amount of data that we have, because maybe we're not interested in seeing the whole thing, but just a specific part of our data set. So in order to reach that specific part, we do need to know about this wrangling process, and these verbs allow us to do it in a very easy fashion. So I'm going to just jump into the examples for you guys to see it here. So do you guys prefer if we see this or if we see this other one? Which one do you prefer?
The other one is fine.
This one. All right. So,
The other one.
or the one from the IDE.
Yeah, it's fine.
All right. So here we are calling our tidyverse, like it will always be calling from a tidyverse. And what I like to do, which is not as the thing that I presented here, is that it's first taking my data set and then piping it through all the needed arguments or verbs or functions for me to reach this point, the graph or the visualization. So here I take my Star Wars data set, which comes with the tidyverse pre-installed, and then I'm going to filter certain values. So here, first, I'm asking to filter all NA values. So is NA shows if a value is NA and gives you a true output, a true value. So if you place this exclamation mark here before, it sort of negates or goes the opposite way around to the is NA argument. So what's going to happen is like it's going to filter all NA values. There are a lot of arguments for doing this. This is the one that I feel most comfortable with. So I'm filtering out NA values for height and mass, which are both metric, right? Height is a metric value for determining one's height, and mass is another metric value. Then, after filtering these NA values, I created a new variable for showing the body mass index, or BMI. And the formula for doing this is taking, the mass and dividing it by the height or the other value divided by 100, and height it to, to exponential. So that calculates the BMI. And then I'm going to select just two variables: the new BMI that I'm creating, and gender, because I'm interested in that specific variable, because I'm trying to figure out how bodies are represented in Star Wars movies. I'm also going to filter. I'm going to just copy this, and I'm going to show you guys how this evolves. All right. So first, I need to load the tidyverse. And then I'm going to go step by step for you guys to see what's going on here. So first, as I said, I filter all the NA. All the NA values for mass and height. just those. And then I advanced and we were here, right? So here we have masculine, feminine, but I'm not sure if that's all the genders that we have. So I'm going to print all the values with this print n equals infinite. And I can see that there are a couple of other NA values here. So I'm going to filter those as well for the gender. And after that, I'm going to be left with a more compact data. And now I can pipe that into the graph. So we're plotting BMI for both genders. Well, excuse me. So as you can see, there's like a difference. Of course, this is not a statistically significant sample or anything, but as you can see, you can answer certain questions with data, and that's like the mindset that I think is needed for using data visualization properly. So you'll find all these examples in the document that it's provided. And let's see, and you'll find a lot of different types of graphs. So, excuse me? I didn't hear that. So yeah, I'm going to talk to Pooja to know how can we share you guys this document so you can reproduce each of the graphs that are provided inside this document. And at the end of this like worksheet, if you can call it like that, I provide like this bonus thingy because sometimes we're not like on the need, or we don't have all the time in the world for producing very, very good looking graphs. And if we are in academia, maybe we are more interested in just getting the results in a publish ready format. And this package, ggstatsplot, which takes upon from ggplot, takes a lot of different tests, statistical tests, and it delivers like all these publish ready graphs. So a lot of things in R, as you see, is like diving into the documentation, getting to know how it's presented, go to the examples, try reproducing them, trying to understand them as they're presented, and also with our own data. And I see that someone's typing, so I'm going